Hi, my name is Ömer Amir Akdağ, and I'm a sophomore computer engineering student at Kent University. In this video, I will represent the basics of my Physics 101 project. This project aims to calculate the optimal angle that the projectile travels the most distance on the x-axis. On the air table, we are supposed to see a parabolic line on the carbon paper. A spring with a known angle fully bent on the corner of an inclined air table throws a puck, and we want to calculate the distance traveled on the x-axis by the puck with different angled springs. Here are the equipments required for this project: a spring, a spark timer, an air table with pucks, pedals, carbon and white paper, a ruler, a wooden block. The procedure of the project is the following. First, the mechanism is prepared as shown in figure 1 with white paper on top of the carbon paper. Secondly, a spring will be attached to the left bottom corner. Then, spring's horizontal and vertical length will be measured to calculate the angle that the puck will be thrown. Both pedals of the air table will be pushed, then the puck will be squeezed into the spring and will be released without any outside force. Then the maximum height and range will be calculated with a ruler from the white paper and the measurements will be recorded. Here are the photos and the videos while I was conducting the experiment. These are the formulas I used while doing my calculations. Theoretically, the maximum height should be maximum when the angle is 60 degrees, because the height increases when the sign value of the initial velocity vector increases. But for the x-axis, formula differs, since the formula for range on the x-axis includes both v0 sine theta and v0 cos theta as products. The optimal angle that the spring provides should be pi over 4, as we can see on the graph here. Here you can see my data table after conducting the experiment in the lab. After I conducted the experiment, I found that my calculations and my experiment data were not the same. There were approximately 20% error with my measurements. These errors were probably caused by friction and the initial velocity. I tried to calculate the initial velocity by the time that it took the puck to fall down. The initial velocity could differ on different angles because the springs were squeezed by hand. Even though I tried to calculate how much I pressured the spring with a ruler, this could be the major reason of the errors. Even though there are some errors while the conduction of the experiment, we still see that the maximum range happens when the angle is 45 degrees as we expected.